In this video, we're going to take a look at trig derivatives. So far we kind of know how to find the derivatives of polynomials and certain rationals. We haven't touched base on trig yet. So in this little box here, it says memorize me. It's there for a reason. These are all the derivatives you would need to know for sine, cos, tan, cosecant, secant, and cotangent. And the best way to really know this for sure is to basically memorize them. Again, hopefully if you do a lot of practice questions, they can't just stick in your head anyway. So I suggest you practice a lot with these type of derivatives and then eventually it'll just stick. So let's do some examples of using some trig derivatives. And the first example, we have x squared times sine x. So we're still going to use those properties we learned about power rule, quotient rule, and product rule. This one's going to be a product rule because we're multiplying x squared and sine x together. So again, if you want to separate them, this can be the first function, this can be the second function. So this could be f of x, and then this could be g of x. And when we use our product rule, we need to find the derivative of each. So let's just find f prime of x on this side and g prime of x on this side before we put it all together. The derivative of x squared is 2x according to our power rule. The derivative of sine x according to our chart is going to be cos x. Now we're going to put it all together for y prime. We're going to need the derivative of f, which is 2x, multiplied by g of x, which is sine x, plus the derivative of g, which is cos x, multiplied by our f of x. And that's it. For our next example, we are now going to use our quotient rule because we have a function divided by a function. Now I'm going to start skipping steps. Instead of writing f prime of x and g prime of x out, we're just going to think about how we're going to differentiate these kind of in our heads. Because you do want to be efficient in the end. You don't really want to write a ton of stuff out. So hopefully you've been doing enough of this, enough practice of using your quotient and product rule that you can just do it in your head now. So first, we're going to find the derivative of our numerator. The derivative of cos x, when we look at the top here, is negative sine x. Then we're going to leave our denominator alone, minus the derivative of our denominator. So the derivative of 1 minus sine x. The derivative of 1 is 0. The derivative of sine x is cos x, but we do have that negative in the front. And then we're going to leave our numerator alone. All of this is going to be divided by our denominator squared. And you can just leave it like that. If you want, you can simplify if you want, but again, you will make more likely to make errors if you do that. So you can just leave it as is. I'm going to move on to C. Now this one's a little bit more complicated because our numerator needs the product rule for us to differentiate, and our denominator is separate, but we can do each term in the denominator. So in this case, it might be nice for you to write the derivatives of your numerator and then the derivative of your denominator on the side. So I'm going to call this one f of x and the bottom g of x. So we're using our product rule here just for the numerator. The derivative of e to the x is e to the x, so it remains the same, plus the derivative of cot x, which is found over here, negative cosecant squared x, and then leave e to the x alone. I'm just going to rewrite this without that negative in there, the plus and the negative in the brackets. So that looks a little nicer there. Now we're going to find the derivative of g. You do it term by term. The derivative of 7x is just 7. And then cosecant x, if you look up here, is negative cosecant x cotangent x. Because we have a negative cosecant x to begin with, this becomes positive because it'll be double negative, and then cosecant x cotangent x. Now we'll put it all together using our quotient rule. We're going to write down f prime of x and this is going to multiply with our g of x minus g prime of x multiplied by f of x. It's a really long answer. All divided by our denominator squared. And again, I suggest you leave it like that because you could make a mistake if you tried to simplify that further. You don't need to simplify unless, remember, the question tells you to simplify. If it just says find the derivative, then just find the derivative and leave it as is. So try these questions on the next page, and then when you're ready, press play to see the solution. Okay, so the solution to D, you're going to use the product rule. So e to the z can be f of x, and g of x can be 5 cos z plus 6 z. And then you're going to apply the product rule on those. In D, you're going to use the quotient rule. The f of x is your numerator, the g of x is your denominator. The derivative of tan x minus 1, you can take the derivative of tan x, which is secant squared x. The derivative of negative 1 is just 0, so it's gone. The derivative of secant x is secant x tan x, and then you're going to follow along with your quotient rule. Let's do another tangent line question. So in this case, we're looking at y equals tan x. We want to find points on that curve, so x values, where the tangent line is parallel to the line y equals 2x. This is a very similar question to one we did in the last video. We are given our slope. The slope has to be 2. So we're going to find the equation for our slopes and then set it equal to 2 and solve for those x values. So we want y prime, or slope, to be 2 because that is our slope in this line. The second thing we want to do is find y prime. So the derivative of tan x, if you look back at that chart, is cosecant, or secant, sorry, squared x. And we were going to set this equal to 2. Now this is going back to grade 12 pre-cal. In order to solve for something like this, we like to deal with sine, cos, and tan. So we're going to change this into terms of cos. So this is the same thing as saying 1 over cos squared x is equal to 2. And another way to write this is if I cross multiply and divide it and rearrange this so that cos squared x is on the top. So cos squared x is actually equal to 1/2. And again, you can just cross multiply and divide to get this. Now we're going to solve for x. Now we need to think about whenever this occurs. And when we take the square root of both sides, we're going to get plus or minus 1 over root 2. This means that this is going to sit in all 4 quadrants. Now we need to find x, which is going to be an angle, and it has to be in radians given our domain here. So your reference angle, if you draw your special triangles out if you need to do that, but your reference angle is going to be pi over 4. So x is equal to pi over 4, and then we're going to think about all 4 quadrants here because it's a plus or a minus, but we also need to think about the domain. So if we think about your domain, if you draw our little unit circle, pi over 2 is over here, negative pi over 2 is over here. So if I'm going from negative pi over 2 to pi over 2, I'm thinking about these quadrants. Quadrants 1 and 4. So that means I only need 2 answers that would fit in this domain. Pi over 4 sits in the first quadrant. Negative pi over 4 will sit in the fourth quadrant. So those are my only 2 answers for x. And then we're done. So take a note. Remember about the domain. So one more try it yourself question that you can try. Find the tangent line and the normal line. And then when you're ready, you can view the solution. You will need a calculator for this one. Okay, so we want to find the tangent line and the normal line to y equals tan x over x. The first thing you want to do is differentiate y. And you're going to use your quotient rule for this. After you find that, you're going to plug in x equals 2 to find what your slope is going to be. This 3.433 is your slope for the tangent line. You have your x value. You also need to find your y value. So you're going to plug in the 2, x equals 2, into the original graph of y equals tan x over x to find your y value. Now you have the x value, the y value, and your slope, so you can plug it into your equation formula. Then you're going to do the same thing, but for the normal line. The normal line is the reciprocal of your tangent line slope. So you're going to do 1 over 3.433, and don't forget to negate it as well. It's your negative reciprocal. So negative 0.291 is your normal slope. And then you already have the point that you figured out before from your tangent line. It's going to be the same. X is equal to 2 and y is equal to negative 1.093. Plug it into your equation formula, and then you can simplify it in the end as well because you do have a calculator. And then that's it.